Yeah, thank you, Shan. Good morning. Greetings from your neighbor in North Carolina. Now, let me tell y'all something about North Carolina. We've got kind of a superiority complex because we definitely think we're better than South Carolina. But then when we look at things like air quality monitoring, wildfire monitoring, drought monitoring, we also think we're one of the national leaders in those areas. But to Shan's point a minute ago, we look at the work that's being done in Georgia, the smoke summits, the exceptional events demonstrations, just the size of the crowd in this room, people that are involved with and interested in prescribed burning. We want to learn from y'all in those aspects. So again, well done for that work, for that interest that you've got down in Georgia. Also great to see that tools like the Prescribed Burn Planner are getting a second life. This morning, I want to give y'all a chance to benefit from what we've done in North Carolina. I want to share a tool that we've developed at the State Climate Office, our Fire Weather Intelligence portal, and maybe see if that's something you could add to your toolkit here when you're looking at planning prescribed burn events and executing those events on the day of a burn. I'll start off with a little bit of history about what this tool is, where it came from. If you go back to that period between 2007 and 2010, we had some pretty bad droughts across the Southeast. That also meant we had some pretty active fire seasons. You see the photo here. This was from a fire in eastern North Carolina back in 2008. It burned for several weeks. It smoldered for several months. After these events were over, the North Carolina Forest Service came to us at the State Climate Office and said, hey, we really had a problem finding the weather information, the fire danger information on the days when these events were going on. Can you build us a tool that just brings that all into a single spot that'll make that part of their job at least a little bit easier? So that's what we did. We built this fire weather portal. We launched it just for North Carolina back in 2013. And then in 2017, we expanded this across the entire Southeast region with support from the USDA Southeast Regional Climate Hub. And then just last year, we went through a round of renovations. We gave the portal a little bit more modern look and feel, and also rolled out some of the things that we had done in North Carolina for other states across the region. So all along, whether it was at the very beginning for just North Carolina or now for the entire region, I would sum up the main purpose of our fire weather portal as this: decision support driven by sound data. So initially thinking back to those big wildfire events, this was giving the Forest Service and their partners who were managing the lands where these fires were burning access to that data that helped them maintain situational awareness, helped them mobilize resources during those events. Over time, we've also found these applications for prescribed burning. So in those cases, it's also giving you access to that same data that can help you plan and execute those events. One thing I always make sure to point out about prescribed burning is the portal is never going to show you yes or no, burn today. Ultimately, it's up to you to use your own training, your own experience in consultation with this data to make that more informed decision. So that's where the decision support aspect really comes in. I'm just curious, how many folks in here have actually used this tool, used our fire weather portal? Okay, that's a decent number. For folks who haven't, I'll give you a very quick tour of the tool, and then we'll talk about some of those applications. So when you go to the website, it's on the rolling slide deck, and I'll also put the link on my last slide. You'll see it's very similar to most other web-based GIS map interfaces, obviously centered around the main map view. I'll point out a couple of other features to know about. One of those up at the top of the screen is this green menu bar. You'll see this is where you'll select the time period that you want to view. And going back to that purpose, these are based around different decision points that you might have. I'll show an example later of past conditions, how you can use that historical data to go back and review an event. When you're looking at current conditions, this is looking at today's data. This is that real-time monitoring information, constantly pulling in the latest observations to make sure you are seeing what's happening right now. And then for forecast conditions, this is looking out mostly over the next 3 to 7 days, kind of that weekly planning horizon, and that can help you identify what days may be good for burning, similar to what we saw with the prescribed burn planner, and then also kind of refine the parameters of that burn, like what time you may want to start and stop. Another thing to be aware of, and it's hard to miss because it's in bright yellow, are the menus here. If you're on the desktop view, this will be on the left side of the map. If you're on a mobile device, these menus will be above the map. These are just where you'll select what you want to see on the map, what region you want to look at, what date and time you're looking at, and which layers or data sets that you're plotting there. So for folks who are new, who have never used the portal before, I just encourage you to jump in, kind of get your hands dirty, zoom in on your area and see what data, what stations are available nearby. So that's what I did here. This was last week when I created these slides, but I pulled up the hourly relative humidity across northern Georgia. You can see here where those weather stations are located across our region. There are none here in Pickens County, but there are some in our surrounding counties. If you want to find out more about a station, just click on it. You can see what site that is. So I've clicked on the Dawsonville Rawls here. To see even more from that site, just click this View More Data link, and that'll pull up this station details panel below the map. On the left, you'll see a summary of other recent conditions, including the fire danger from this station. On the right, we have what we call our meteogram. It's just a graph of the recent history of the data set we're looking at, in this case, the relative humidity. You can also see the wildfire response applications for this. Looking at these 7 days of humidity values, you can see what that nighttime recovery has been like. It was pretty good at this site, most nights getting back to around 100%. And then also what those lower afternoon values were, down around the 50% range. I'll briefly summarize the different data sets that we have available. There's more than just I'm showing on these slides, but again, just don't have time this morning to go over everything. So for weather station data, as the name implies, these are observations from individual weather stations, mostly raw stations, but also some of the Weather Service's airport-based stations across the region. That includes things like the humidity that we just looked at, also precipitation totals over different time scales, ranging from the past hour all the way to the past 90 days. This is also where you'll find your National Fire Danger Rating System, estimates, and fuel moistures, as well as the 7-day forecast that the local Weather Service offices across the region are issuing. One note about this, if you're looking at the fire danger or fuel moisture data, you will be seeing the fuel model for each station based on its default in its fire danger rating area. This is one of the new renovations that we rolled out last year. The U.S. Forest Service provided us with these fire danger rating areas and the fuel models for each. You can see on the map here in northern Georgia, the default is fuel model Y. Also down right at the coastline, they're using fuel model Y. And in between across the Piedmont and the upper coastal plain, the default is fuel model Z. If you ever want to change this and look at a different fuel model, if you open up that weather station data menu, there's an advanced settings option. In there, you can change which specific model you're seeing. So if you want to see what model Z is showing here in northern Georgia, that's how you would do that. Separate from the weather station data, we've also got what we call our gridded and spatial analyses. Instead of being individual data points from specific locations, these are more continuous data sets. They give us better coverage, kind of filling in some gaps across the region. That includes things like radar-based precipitation estimates and a gridded KVDI product that we're calculating. Also, we're bringing in soil moisture and greenness data from NASA, and then some Weather Service products, including their dispersion forecast, fire weather zone forecast, again, within that 3 to 7 day planning horizon, and then also some longer term temperature and precipitation outlooks. So again, there's no way we can go over all of this in 25 minutes this morning. So I wanted to highlight 5 features that I think you all should know about and start using in your own prescribed burn planning with the fire weather portal. The first one of those is a few different ways to look at recent precipitation within a context that makes it easier to determine, is it too wet or too dry to burn? One of those is looking at the number of days since a wetting rain event happened. Now, what's classified as a wetting rain event just depends on kind of where you're at, what your applications are. In some cases, it could be as little as 1/10 of an inch. In some cases, like in North Carolina, we tend to look at 1/4 inch in a day as a good wetting rain. And if you look at NRCS guidelines for prescribed burning, they say it's best to burn 1 to 3 days after at least 1/2 inch of rain. But all 3 of those thresholds are available in the portal. And I'll show an example in the next slide of what that looks like. And again, also we're looking at things like radar-based precipitation, calculating a percent of normal to give you that climate context, and then also that gridded KVDI that I'll give an example of. First off, this was again from last week, the number of days since at least 1/4 inch of rain across northern Georgia. Most areas were in that 5 to 10 day range. maybe a little bit longer than you'd want based on those NRCS guidelines, but not too high that you would be worried about just uncontrolled burns. What we've noticed in North Carolina is when these numbers get above 20 or 21 days, that's 3 weeks without a good rain. That's where you can start to have some initial attack problems with wildfires. So we don't like to see the red colors on this map. We're pretty happy if they stay green like this. Here's an example of that gridded percent of normal precipitation. I'm sure to nobody's surprise in here, after the wet May we had, the wet end of spring, most areas are above normal right now. Just a few very slightly dry areas in places like Hall and Banks County, northern Franklin County. If we saw more pronounced dryness, like let's say areas down below 50% of normal, then that could be a sign, hey, maybe I don't want to burn in these areas. Maybe those larger fuels are still pretty dry. Maybe that could cause me some problems on a burn day. And then finally, here's our gridded KBDI product. We just updated this last year, so it's a little bit more accurate. It tends to track better with some of the weather station estimates. I know KBDI is one of those things we tend to use more for wildfire applications. How difficult is mop-up going to be if a fire occurs? But this can also be useful just for your situational awareness. Are these values creeping up? Are they pretty much staying even? Again, they're pretty low right now. Most areas in that 1 to 200 range. If you want to see a specific value for a point, just click that point on the map. In this case, last week in Pickens County, we were seeing those values of 117 or so. Assuming it's the same as in North Carolina, that is a very low KBDI for this time of the year. So again, speaks to how wet we've been lately. The next feature I'll highlight is the dispersion forecasts that are coming from the national blend of models. This is one of the National Weather Service's products. Basically, they're taking a number of existing weather forecast models, combining those together, and you're getting the skillful benefits of the average. So where those models converge, you could have more confidence in what they're showing. You see here some of the things that are included in the standard output from the national blend of models, and then some of the additional things that we're calculating at the State Climate Office. It's probably easiest just to show this with a couple examples. First off, here is the atmospheric dispersion index. I pulled this up last Wednesday, but looking at a forecast for last Saturday. So again, within that 3 to 7 day horizon. One thing I really like about gridded data sets like this is you can see that variability across the region, even within specific counties. In this case, we were seeing lower values in far northwestern Georgia. As you got further south and east, including here in Pickens County, those ADI values were in that 60 to 100 range, usually pretty ideal, at least for dispersion when you're thinking about burns. And then further south and east from here, we were seeing higher values, over 100. In those cases, you're getting this explosive dispersion, maybe some control problems. So again, this could hone in on exactly which areas would be best for burning based on that dispersion factor. Also, when you're thinking about dispersion, you want to think about where any residual smoke might go after the burn is finished. So I encourage folks to look at things like the low visibility risk. This was looking at the forecast for this past Sunday morning. So again, the hours after a fire would have ended. Most areas across northern Georgia were kind of in that moderate 3 to 6 range on a 1 to 10 scale. But we did see some areas like western Pickens County, Gordon County, that were at a much higher risk, values of 8 or 9. So for folks that were planning burns, if they were looking at this, you might say, well, I better make sure there was no more smoke into the overnight hours, because that could create some visibility hazards. The next thing I'll mention is a calculated fine dead fuel moisture product. In the portal, this is under the weather station data menu and then under the fuel moisture conditions section. It is listed right there with the fine dead fuel moistures you're getting from the Nelson models out of WIMS. I will note that this is not directly comparable with those fuel moistures. This is actually using the older Fosberg fuel moisture method that was part of the old fire danger rating system. A couple big reasons why we're still including that here. Number one, in North Carolina, on our prescribed burn plan, there is still a space for Fosberg fuel moisture. So folks, as they're planning burns, can just go and look and see on the map what that value is in their area. Also, the nice thing about this is that you can calculate it just based on hourly weather observations, your temperature and your humidity. So that means we can update this every hour throughout the day. So if you're out at your burn site, I'd encourage you to just pull this up, see how that fuel moisture is changing hour by hour, and see if it matches with what you're noticing on the ground in those fuels. A couple caveats I'll note with this. This is assuming a south-facing aspect in that lowest 0 to 30% slope class. Obviously, here in northern Georgia, when you get in some of the higher elevations, that may not be true for your area. So again, use your best judgment, but if it's not matching with what you're seeing in the field, you may need to pull out this pocket guide and just do that calculation based on your own measurements. So here's an example of this from last week. Again, this was mid-morning looking at the unshaded calculated fuel moisture. Most areas in that 10 to 15% range, so no real concerns there. And just like we did with the humidity, we can pull up that graph that shows how this has been changing in recent days. This also shows what that nighttime recovery has been like, and then what those drier afternoon values had been. On the previous day to this, around 2 o'clock, we had seen values of about 8%. So assuming weather and fuel conditions aren't changing too much, you might expect something like that on the next day. One thing we've already heard a lot about this morning is air quality observations and the importance that those play. Again, air quality monitoring is part of the smoke management plan in both North Carolina and in Georgia. And with the new NACs, that's become even more important to make sure we're maintaining that good, healthy air quality. So as a tool for doing that in the fire weather portal, we're showing the current daily average PM 2.5 concentrations. Basically, if the day were to end right now, as of the last hour, where would we finish on this AQI scale? And to do that, we're including both the regulatory monitors that are being used for calculating those attainment and exceedances, and also the Purple Air Network. These are lower cost sensors that are a little bit more affordable and more widely available. That can give you a sense of between those monitors what the air quality looks like. So here's an example again from last week. It was one of those kind of hazy days when we had some of that Canadian wildfire smoke coming in. We were seeing pretty widespread code yellow conditions by the middle of the day based on that current daily average. And then there was even one monitor up in Murray County that was at the code orange level. In North Carolina smoke management plan, we discourage any burning once you get to the code orange level, and it's not recommended to burn when you're in those higher code yellow values either. So again, this can just be an additional tool. If you were to look at a map like this, see that we're already at that code yellow level in most areas, maybe think twice about burning. Certainly you would save Deanna and her team a little bit of work on another exceptional event, but also you would keep more smoke out of an airshed that was already pretty polluted. The final feature I'll mention here, and I talked about this earlier, is just using that past conditions tab to go back and review what things were like on the day of a burn, whether it was a successful burn or whether you had some challenges. If you made your own on-site observations or measurements, this is a way you can compare what actually happened with what you saw on site, see which weather stations tracked closest to what you noticed on the burn site, and also you can compare with your spot forecast. So Ty, you recommended folks use this. Here's your chance to hold Ty's feet to the flame. Not literally, but see if that forecast verified with what you noticed. We've also found some utility in North Carolina with checking for what we call unexpected responses, when things maybe didn't go exactly like you thought. As one example of this, the Nature Conservancy did a burn a few years ago in the wintertime down in the Sandhills. It was a big longleaf pine stand. After the burn, they noticed that on some of the larger pine trees, they were getting some scorching really low down on the trees. So they wanted to see if the weather might have had any impact on this scorching. So they went to the portal, they pulled up the conditions nearby. Another feature when you're looking at the weather station data, you can select up to 4 different data sets and see those all plotted on the map for each station. So in this case, they pulled up the temperatures, the humidity, the winds. Nothing looked out of the ordinary there. Humidities are in that 50 to 70% range, which seemed okay. That let them rule out weather as a factor. And when they looked back at some of the photos they had taken from before the burn, they noticed there were lots of saplings with some needles that were burning hot. That was creating that scorching problem that they noticed. So again, a good way to help see whether the weather could have been factors in things like that. A couple of the things I'll mention here, if you see a map like this and think, this is great, I want to share this, I want to save this, there's a couple ways to do that. If you want to take a screenshot of a map that you see, just click on the camera icon down at the bottom right. That'll save an image to your computer with that map view. And then if you want to share a link to this page so that others can go to it or so that you can come back to it later, just click the link icon up in that top green menu, and that'll let you copy and paste the link that, again, you can save or share with others. Just wrapping up, a couple other things I'll mention briefly. First, if you haven't heard, there is a change coming to our fire danger data over the next few months. The old WIMS database that's been the standard for probably 20 years now is finally going away. It's being replaced by a new tool called FEMS, the Fire Environment Mapping System. The biggest change that'll happen there is it'll include hourly fire danger estimates. So instead of having that once daily 1 p.m. value, we'll now have those hourly values throughout the day. It should give us a much more accurate idea of what that fire danger is and when it's occurring. Because we know at this time of the year, the hottest time of the afternoon is not usually at 1 p.m. It'll be a few hours later. So stay tuned for more on that. Right now, the transition, it sounds like, is planned for September. We will be incorporating this hourly data in the portal as we can get our hands on it. If you want to know more, I'd encourage you to go to the FEMS website to see some of their material. One final plug I'll put in North Carolina, we found it really useful to be able to look at the fire danger and fuel moisture data in an historical context, specifically as an historical percentile. The map you see here is looking at the 100-hour dead fuel moistures. Here we can see some areas in eastern North Carolina were above the 90th percentile, while one of our fire danger rating areas further west was down at the 17th percentile. At a glance, that just makes it easy to see, is this area wet or dry compared to normal? I would love to set this up for states like Georgia as well. To do that, we would need some longer historical data, like 20 years of data from your weather stations, your RAW stations, and also need to know for each of these fire danger rating areas when your fire days, your large fire days, and your multi-fire days have happened. So especially if anyone from Georgia Forestry Commission's here, if you have this data, get in touch with me because I'd love to set this up. I'll wrap up there. If there's time for questions, happy to take any now. Otherwise, catch me throughout the day or send me an email. And most of all, encourage folks to check out the portal, see how it might fit into your own prescribed burn plans. So thank you.
Thank you, Corey. Meeting at the portal.